we will move on to the next part of this atomic radius. Yeah, guys, we discussed that there were two kinds of atomic radius. One is what an covalent radius, and second one is what an metallic radius. Okay, if the elements were non-metals, then the radius is considered as an covalent radius. If the elements were metals, then the radius is considered as a metallic radius. Okay, and in your chapter, these two will be considered as an atomic radius. Okay, yeah, guys. Now we will move on to an variations of your atomic radius in the periodic table. Okay, how it will vary in the periodic table. That is what we have to discuss now. Yeah, guys. When we consider and variations of atomic radius, here there were two trends, that is what, down the group and along the period. Okay, along the period and down the group, there were two trends, that is what, down the group and along the period. Okay, if you consider variations of atomic radius down the group, atomic radius will increases. Okay, now, yeah, down the group, atomic radius will increases, whereas along the period, atomic radius will decreases. Okay, here there were two trends in the periodic table. One is what, down the group, atomic radius, how it will varies, and along the period, atomic radius, how it will vary. Okay, if you have and doubts regarding this, means down the group atomic radius increases, whereas along the period, that is not an horizontal rows. This is what an vertical column. Along the vertical column, atomic radius increases. Along the horizontal rows, atomic radius decreases. Okay, here first I will consider along the period. We will discuss now. Here along the period means, if you want to consider a second period number 2. Here guys, the variations from lithium to neon, right? Variations from lithium to neon. What is the general trend? The general trend along the period, atomic radius has to decrease. That means what? When you guys were moving from lithium to neon, the atomic radius should be less. That means what? Lithium will have more atomic radius, whereas your neon will have an less atomic radius. Okay, now here when we move along the period, if you consider a second period, I will take an example for this second period that will start with a lithium element and ends at a neon, right? According to the general trend, along the period, atomic radius decreases. Here the lithium, which will have an highest atomic radius, whereas neon will have an least atomic radius in your periodic table, and that too in second period. We are discussing of second period means lithium will have an highest atomic radius, whereas neon will have an least atomic radius. Okay, here then guys, what is the reason for this? You know that if you are moving along the period, you guys are moving along the period, atomic number will increases, whereas and also the effective nuclear charge will increases, and number of protons will also increases, and the number of electrons will also increases. Okay, number of electrons will also increases. Okay guys, the major thing you should observe here, along the period, our general concept, atomic radius will decreases. And what is the reason for this? Here guys, you look at me, right? Here, this is what an atom means. In the in the variations of periods, we will have the same quantum number. Yeah, in the complete period, we will have the quantum number with and same. That means what? If we consider an second period, your quantum number is 2. If you consider third period, the principal quantum number is 3. Okay, like this, for each periods we will have an same principal quantum number. So that here one thing you guys should observe here, because we are having a same principal quantum number in the along the period variations, the electrons present in an atom will enters to the same orbitals. Enter to the same orbitals. So that here, if the electrons were entering to the same orbitals and your nucleus positive charge, that means what? And protons were also increasing in the nucleus. You know that guys, electrons were negatively charged, whereas your protons were positively charged. Okay. Along the period, the principal quantum number will be same, so that electrons will enter into the same orbits, and the proton number, that means what? And positive charge in the nucleus goes on increasing out, so that increasing positive charge, electrons were adding to the same orbital, so that there is a greater attractive force between your positively charged nucleus and the negatively charged electron. Okay, here the positively charged nucleus is considered as an effective nuclear charge. If I am telling out effective nuclear charge, means you guys should observe that we are discussing out an positive charge of the nucleus. Okay, here the major thing why the atomic radius will decrease along the period means because of the presence of same principal quantum number, so that the electrons will enter into the same orbital and the positive charge, that means what? Effective nuclear charge of the nucleus is increasing. Okay, and you guys knows that this is what a basic concept. The positive and negative charge were always attractor. That means what? Positive charge will always attract negative charge, and negative charge will always attract positive charge. So that here positive charge increasing in the nucleus means electrons were here means there, if you increase a positive charge, then there is an more amount of attractive force between your positively charged nucleus and a negatively charged electrons. If attractive force were increasing out, obviously size of the atom will decrease. Obviously size of the atoms will shrink, so that atomic radius will be decreased. Okay, atomic radius will be decreased. So if you move down the group, what is the general trend? Again, if you move down the group, the general trend is what? Atomic radius will increase. Okay. Here guys, look over this one. Down the group means we will consider a vertical column. Right? You can take your second or first group you will consider, and first group elements, that is what are alkali metals. Okay, alkali elements or alkali metals. Here, if you move down the group, generally the principal quantum number increases, right? Here for your hydrogen, 1 is their principal quantum number, lithium 2, next sodium 3, potassium 4, so that it will increase. Okay, down the group, the principal quantum number is increasing means here an atom, hydrogen, nucleus, 1 orbit is there. Principal quantum number means what? Here 1 orbit is there. For when you move on to a second element in the same group, that is what a lithium, this is having 2 principal quantum number, so 1 more orbit is increased. When you move on to a sodium, again it is having 3, so another orbit is increased. Next if you move on to a 4, that's again one more orbit is increased out. Here, look out these pictures. As the principal quantum numbers were increasing down the group, orbitals were moving far away from your nucleus. That means one orbit is adding one by one. Okay, that means adding of orbit will take place. Whereas along the period, the same orbital is there. We are adding an electron to the same orbital. In the case of down the group, as the quantum numbers were increasing out, number of the orbitals were also increasing. That means we are adding electrons. For your hydrogen, we will add here electrons. Whereas your sodium, we will add an electron here. Lithium, we will add here. And the sodium, we will add here. And your potassium, we will add the electrons like this. That means the electrons were moving far away from the nucleus. Electrons were moving far away from the nucleus means there is an increase in the distance of nucleus to your outer electron. Nucleus to your outer electron. So that will obviously indicate that atomic radius down the group will increases, because as the principal quantum number increases, number of orbitals will increases as we move down the group, so that the distance between your nucleus and the outermost electrons will increases, atomic radius will increases. Okay, did you got this one, guys? Here down the group, an extra orbit will add when you move from one period to and second period to third period, like that. That means extra orbit is adding means the distance from the nucleus and the outer orbit is increasing. If it is increasing means obviously atomic radius will increases. Okay, this is what I am complete concept how the atomic radius will increases down the group and how it will decreases along the period. Along the period, same orbit we are adding electrons to the same orbit, whereas down the group we are adding orbits and an electron to that new orbit. Okay, here 1 for your hydrogen, 2 for your lithium, 3 for your sodium and 4 for your potassium. Like that, here there is an increase in an orbital number and we are adding an electron to this increased orbit, new orbit, so that the distance from the nucleus and your outer orbital will increases, atomic radius will obviously increases. Okay, this is what I am two major difference here. Along the period, we are adding electron to the same orbit. Down the group, we are adding a new orbit. To that new orbit, we are adding an electrons. So that as we move down the group, orbitals numbers were increasing out and the distance between nucleus and the orbit were increasing out, so that atomic radius will increasing. Okay, so this is what a complete picture how your atomic radius will increases down the group and how it will decreases along the period. Okay, did you got this one now, guys? This is about the variations of atomic radius down the group as well as along the period. Two more questions. Define atomic radius, half of the distance between the two covalently bonded atoms, or half of the distance between two metallic bonded atoms. Okay, down the group atomic radius increases, along the period atomic radius decreases. Okay, this is what a complete picture. Here, if the ask can give reason why atomic radius is increasing down the group means, then you guys has to answer like this. The reason is what? As we move down the group, the principal quantum number were increasing, so that number of orbitals were increasing. So attractive force between the nucleus and the outermost electron decreases, atomic radius increases. When it comes to along the period, we are adding the electron to the same principal quantum number and we are adding the electron to the same orbit, and one thing, effective nuclear charge is increasing out in this concept. That means we are adding electron means you have to add a proton there. One electron and one proton, then that will move to a next element. Okay, you should along the period you guys were moving out means then positive charge of the nucleus is also increasing. Okay, and so the positive charge increases means effective nuclear charge increases. Effective nuclear charge increase means attractive force between your nucleus and the outermost electrons will increases. So attractive force increase means obviously shell will shrink its size. That means atom will shrink its size. So here effective nuclear charge increases or not? Obviously here also effective nuclear charge increases, but the distance is too high between your nucleus and the outermost orbit. Okay, completely. This is one major reason why the atom in along the period atomic radius decreases, whereas down the group atomic radius increases. Okay, along the period you guys were moving out points, atomic number is increased, effective nuclear charge increased, and number of protons were increased and number of electrons will also increase. These things will be same here also when you move down the group, but the only condition is distance between these two will increases, so attractive force will decreases, so that atomic radius will increases. Okay, if positively charged nucleus and negatively charged electron, distance between these two were less, more will be the attractive force, less will be your atomic radius. If distance between these two is high, less will be the attractive force, more will be the atomic radius. Did you got this? This is about complete picture of how your atomic radius will vary down the group and along the period. Okay, and one more thing I have to explain you, I want to explain you guys, that is what and noble gases. Okay, in the group number 18 we will have a noble gases. They are noble gases. We won't consider your covalent radius as well as a metallic radius. Okay, for your noble gases we won't consider covalent as well as your metallic radius, because these elements will exist as an monoatoms. That means what? These elements will exist as a single atom. These elements will exist because it will have a stable electronic configuration, that is what? NS2 NP6. And I told you that this is what? Unstable electronic configuration, and these were highly inert in nature. Inert is nothing but what? Less reactive in nature. Okay. Here, then how we will calculate the atomic radius of this noble gas? Because it won't form a bonding between the atoms. It exists as a monoatom. That means single atom. It will exist as a single atom. Whereas your chlorine, when you consider a chlorine, that will exist as an Cl2. That means two atoms are linked together. Copper, that is arranged in your crystal lattice, and you can easily calculate distance between the two atoms. Whereas your noble gas will exist as a single atom, only one single atom. So again, you know that this electron cloud is not a sharp boundary, it is what? An dispersive boundary. So we can't calculate the distance between these two. So when we are calculating the atomic radius for noble gases, we won't consider an covalent bond or a metallic bond. We will simply consider an van der Waals force of attraction. Okay, here in your van der Waals force of attraction, when you consider a noble gas, you guys has to take the van der Waals of force of attraction between one noble gas atom with the other atom. Okay, if it is what noble gas atom, this is what an other atom means, then here to calculate atomic radius, you guys do not consider an covalent or a metallic radius, you just consider van der Waals force of attraction. Okay, here the only van der Waals force of attraction, by the weak van der Waals force of attraction, your noble gas will form and molecules with an other element. Okay, this is about how we will calculate atomic radius of noble gases. Okay, This is what a complete thing of variations of atomic radius in the periodic table. Okay.